Now see the next theorem, angle bisector theorem part 1. What is the statement? Every point on the bisector of an angle is equidistant from the side of the angle. See on your textbook page number 40. So what is the given? The ray QS is a bisector of angle PQR. This is angle PQR and this QS is a angle bisector that divides into two equal parts. So segment AB, this segment AB perpendicular to this ray QP and this segment AC that is perpendicular to ray QR. So this angle bisector divides into two equal parts and we get these two triangle. So triangle, first triangle, that is triangle BQA. This triangle BQA and triangle here CQA. So in this triangle there is the QA is a common side. So we write here segment QA congruent segment QA. Write here reason, that is common side. Okay. Now what is next one? That is the angle BABQ and ACQ. That is each 90 degree. They are perpendicular. So this also called congruent. So angle ABQ congruent angle ACQ. That is each 90 degree. Okay. Now next third one, that is the BQA and here CQA. This angle also congruent because this is the angle bisector divided into two equal parts. So this is two equal angles. So here write BQA congruent angle CQA. That is given. So two equal parts divide. So therefore this is our three conditions. So this two triangles are congruent by which test? There is the side angle SAA. Therefore triangle BQA congruent triangle CQA. So SAA test. So what is the remaining part? That is there AB congruent for AC because the corresponding side of congruent triangle. So segment AB congruent segment AC CSCT. So this we prove. See the next part of this angle bisector theorem part 2. So what is the statement? Every point on the bisector of an angle is equidistant from the sides of the angle. So what is the given? A is a point in the interior of angle PQR. This angle PQR and point A is interior of this angle. So segment AC is perpendicular this ray QR and segment AB perpendicular ray QP. So AB equal to AC. Now what to prove? That is ray QA. QA is the bisector of angle PQR. That is the angle BQA equal to CQA. So this we draw, we get this two triangle. See the angle bisector theorem part 2. What is the statement? Any point equidistant from sides of an angle is on the bisector of the angle. This is the reverse part of part 1. So what is the given? A is a point in the interior of angle PQR. Angle PQR, this is the interior point. Then segment AC, that is perpendicular ray QR and segment AB perpendicular ray QP. That is AB equal to AC. Now what to prove? That is ray QA. QA is a bisector of angle PQR. Okay, and this angle BQA equal to angle CQA. So this is the angle bisector. We get this two triangle. So here I write triangle BQA and triangle CQA. So first here is the QA. This is the 90 degree and this also 90 degree. So this is the hypotenuse opposite side of 90 degree. So hypotenuse QA congruent hypotenuse QA, that is common side. Now what is the second condition? That segment AB congruent segment AC given. So segment AB congruent segment AC, that is given. Okay. Now next third one, that is this angle 90 degree, this also 90 degree. So angle B congruent angle C, that is each 90 degree. So these three conditions are satisfied. So hypotenuse side, so these two triangles are congruent by which test? Hypotenuse side test. So triangle ABQ congruent triangle ACQ. Which test? Hypotenuse side test. Okay. Now what is the remaining part? So remaining part, that is the CQA. So angle CQA congruent angle BQA, that is corresponding angle of congruent triangle. This angle also congruent, and therefore so our QA is bisects angle PQR. So this QA is bisect this angle PQR. Now see the next part, that is properties of inequalities of sides and angles of a triangle. This related to three theorems. So what is the first statement? Is if two sides of a triangle are unequal, then the angle opposite to the greater side is greater than angle opposite to the smaller side. So here the angle triangle, that is XYZ. In this triangle, side XZ, this XZ is greater than side XY. And to prove, that is angle XYZ greater than angle XZY. So angle opposite to greater side is greater and angle opposite to smaller side is smaller. So XZ, this side XZ, opposite angle is angle XYZ, and XY, this side opposite angle is XZY. So here two sides are unequal. So we don't know measure of any side. Then also we compare opposite angle of XZ and XY. So here is this side is a greater. So this angle also greater, and this side is a smaller than this side. So this angle also smaller. So this can be proved without measure. Now we see the second theorem. That is statement is second theorem. That is the reverse of this first theorem. That is, if two angles of a triangle are unequal, then the side opposite to greater angle is greater than the side opposite to smaller angle. Here we see the side greater and angle then related to angle. Here first we see the angle greater and then the side also greater. So in this theorem, there is the triangle given ABC. This is the triangle, and in this triangle there are, in triangle ABC, angle B greater than angle C, and prove that AC greater than AB. So this is the greater angle. So opposite side of angle B is AC and opposite side of angle C is AB. Therefore this is the greater angle. So this side also greater. This is a smaller angle. So this side is smaller than this side. So AC greater than AB. When two angles are unequal, side opposite greater angle is greater and side opposite to smaller angle is smaller. So this is the converse of this first theorem. So now next one, that is the third one. Here see the statement. The sum of any two of a triangle is greater than third side. What is the sum of any two side? Here the triangle ABC is any angle, and sum of any two side is greater than third side. Here AB plus AC greater than this is BC, and then AB plus BC greater than this third side, and AC plus BC greater than this third side AB. So this is three theorems related to these properties of inequalities of sides and angles of a triangle. So we solved some example related to this concept in practice set 3.4.